If we define A to be the set 1, 3, 7, 11, 19, there are 5 elements in A. B, the set you see here, there are 1, 2, 3, 4, 5, 6, 7 elements in B. Then if we form A union B, that means we throw both sets together. It would seem that we should have how many elements if we do A union B? Think about that for a minute, maybe pause. It would seem at first that we'd expect to have 5 elements from A and 12 from B, which would give us 17 elements. However, if we form A union B, we note that certain elements, like 11, appears in both sets. When we form A union B, 11 is only going to be listed one time. So instead of having 5 plus 7, which would be 12, well, that's going to reduce us down by 1, because if we listed all these, if we listed 11 twice and we listed 7 twice, 7 being the other element that's common to both sets, we would have 12 elements. But we'd have to throw away one of the 11s. We don't list elements twice. It doesn't count the second time. It's already listed. And we'd have to throw away one of the 7s, which would leave us with only 10 elements, wouldn't it? Now, if we form the set A union B, okay, and we're testing whether the number or the cardinality of A union B is equal to the cardinality of A plus the cardinality of B, we find that it's not so. Okay, so we say no. A union B consists of what? 1, 3, 6, 7, 8, 9, 10, 11, 12, and 19. That's 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10 elements. Now, we already reasoned out a minute ago that there should be 10. What was our reasoning process? The number in A plus a number in B is 5 plus 7, or 12, whereas the number in A union B is 12 minus 2, which is 10. How did we reason out 12 minus 2? We said that there were 2 elements that were going to get counted twice, the 7 and the 11. Had we listed all 12 elements, all the elements of A and then all the elements of B, the 7 and the 11 would have been listed twice. So we take the 2 away. Now, what are the 2 that we took away? Again, the 7 and 11, because they appeared in both sets. See if that doesn't make sense of the following. The number in A union B is a number in A plus a number in B minus the number in A intersection B. Why do we subtract the number in A intersection B? Because if we just list all the elements of both sets, there will be this many elements, n of A plus n of B. But we can't list the ones that are in both sets more than once. So we're going to have to reduce this total by the number that's in both sets. We subtract the overlap when we calculate this sort of thing. Okay, so this shows why the number of elements in A union B is the sum of the numbers in A and B minus whatever's counted twice, which is the intersection.